In this video, I'm going to go over how to construct confidence intervals using the T-distribution. Now, this is going to be actually very similar to how we constructed confidence intervals with the Z or the normal distribution. The only difference is really going to be in a few steps where we have to obtain the critical T value. We have to do a few different things. Otherwise, it's almost nearly identical. If you recall, the Z distribution and the T distribution are very similar, although the key difference with these two distributions, as you see, as is talked about in the book and also videos associated with the book, is that with very small sample sizes or very low numbers of observations, there's more weight in the tails with the T distribution because there's more potential for outliers or very larger amounts of variability. So we're going to want to account for that using the T-distribution. And so if you ever hear the word like a t-test, that is a test that's using the T-distribution. And it's actually a very common test, especially in psychology, where we have a lot of experiments that have lower, smaller sample sizes. So let's go over the steps. First, the steps are we're going to get the critical T value. That's what we're going to plug in to this formula here that's going to determine our confidence interval. So just to review, the formula for the confidence interval is the point estimate or the mean. It doesn't always have to be the mean, but it's the mean in this case, plus or minus. So we're getting two values, one above and one below the mean. The T distribution, critical value of T times the standard error. In order to get this critical value of T, we need to first determine the number of observations in the sample, and we're going to subtract 1 or n minus 1 to get the degrees of freedom. Now this is the parameter that the T-distribution is based on. Once we've determined the number of degrees of freedom, we're going to use this stats app or this website to determine our critical T value. And we want to use the probability, which is 1 minus the CI width, for a two-sided test to get the correct critical value. And remember, if we remember from previous videos, that 1 minus the CI width is otherwise known as our alpha level. So let's go into Google Sheets. And we're going to work with the same data set. So in the previous video, when I talked about sorting and filtering, we had our basic, our original data set that's data, and it's got this lock bar. And we created data 2 to be the one that we're actually going to go and mess around with. And so I'm going to scroll all the way to the right, and we're going to actually perform our calculations over here to the right rather on a separate sheet. So let's just go ahead and write the things. Let's say we want to get the mean for, let's use this variable happiness at the beginning of the semester. So we're going to say happiness mean 1. 1 just indicating that this is the start of the semester. We're going to, actually, you know what? Let's just say happiness 1 meaning start. And when the things that we need to get, if we recall, are we're going to need to calculate the mean, we're going to need to calculate the standard deviation, we're going to need to calculate the number of observations, or we'll just abbreviate this as n. We're also going to need to calculate the degrees of freedom, and then we're going to calculate the standard error, and then we're going to get a critical T value. And then this is all the information that we're going to need to calculate our confidence interval. So then we'll type in our lower CI, and we're going to do a 95% one, and then we'll type upper CI, and we'll do a 95%. All right. So let's go ahead and calculate our mean. So we're just going to type our equals, and we're going to type in average, parentheses. We're going to go over here to happiness at the beginning of the semester, just click on that column, and we get a mean of 5.11. So somewhere in the middle, let's round to the 100th so it's nice and clean. Let's go ahead and get our standard deviation. Just like we almost identical steps as before. You get a standard deviation of 2.78. Let's go ahead and clean that up, round that to the 100th. Number of observations. Now, I could tell you that this is 60 because it's a rather small data set. But let's just use a different function that we haven't seen yet. We're going to use the count function. And if we type count, we can see the definition of the count function is count of the numeric values in the data set. So it's only counting numeric values. And we just click right there, and we get 60. Now, if you remember, our degrees of freedom is 1 minus the number of observations. So we're just going to hit equals. We're going to grab our number of observations. We're going to subtract 1. Obviously, most people could do this arithmetic in their head, but we get 59. So, and then our standard error, if you recall, the formula for standard error is just our sample standard deviation divided by the square root of the number of observations. So let's go ahead and calculate that. It's equal to our standard deviation divided by the square root, so we're going to call that function, of the number of observations, which is 60, and that with the parentheses, and we get a standard error of 0.35. Let's go and round that down. So now we need to get this critical t-value. We have the number of degrees of freedom. We know that our width of our confidence interval is 95, proportion of 0.95 or 95% confidence interval. So we're going to go to the link, and it's going to link to this page. And again, this is what we used earlier. We were calculating a z ratio based on a probability. Now we want to use the t ratio. And we don't want to use the f ratio or the chi-squared. So remember, this is 1 minus the proportion of our confidence interval. So it's going to be 1 minus 0.95, which is 0.05. Our degrees of freedom, if you recall, is 59, or 1 minus the total number of observations. We're going to compute t. And we get a two-tailed t-test of t equal to 2.0010. So let's bring that over into Google Sheets. We'll put that right there. And now we have everything we need to calculate the confidence interval for the first happiness. So now we're going to click equals, and remember our point estimates are mean. We're going to say subtract, because this is the lower bound, the z times the standard error, and we get 4.40. Now to get the upper bound, we'll just click on the cell corresponding to the mean, plus the critical value times standard error, 5.83. So this 4.40 and 5.83 represents our 95% confidence interval for happiness at the beginning of the semester. Great, so now we've done that. Now I want to show you a quick thing, what'll happen. Let's look at what happens if we actually sort the data. And this is one of the reasons why we don't actually want to always perform all our calculations in the same sort of data, in the same spreadsheet as our data. Because if we go over here and click sort A to Z, remember how it jumbled everything up? Now it's jumbled up all these calculations, in a sense made everything meaningless. So let's not do that. Let's unsort. We can just probably undo that. Let's go over here to undo. There we go. Everything's back to normal. So that's one reason why you don't always want to what am I trying to say? So perform your calculations in the same area as our data set. We're just doing that to show you simply these basic calculations and do the confidence interval. So in this video, I've shown you how to kind of calculate the confidence interval using the t-distribution. I want to show you one more thing with this, is I want you to show you how to do, and this is building off the previous video with sorting, how can we actually create a confidence interval just around one mean. or like say, and let's say that's or excuse me, one subset of the data, let's say psychology majors. So let's say we wanted to know the happiness at the beginning of the semester of psychology majors. Well, one way to do that is I mentioned the easiest ways to kind of use this sort function. So let's go ahead and delete this so we know it's going to jumble this all up. Actually, I'm going to copy these values because we're going to know we're going to have to calculate those. And actually, we'll just copy all this stuff. And now we're going to sort. Now we've copied it. We'll delete it. We'll sort A to Z. So now everything's kind of right next to each other. We can see the psychologies are all right next to each other. We're going to go to this cell right here. We're going to paste it. You notice how these are all correspond to the means for happiness at the beginning of the semester for all the observations. But remember, we just wanted a subset of just psychology. So let's delete our mean, our standard deviation, our number of observations, and we're going to have to calculate a new critical value. So our mean is now going to correspond to the average of just these guys, because these all correspond to psychology. And you notice that I didn't end that with the brackets. I just hit the return button. You don't have Google Sheets will actually automatically know if you leave brackets open and you just hit enter, it closes those brackets for you. It's a nice little catch that it does. You don't can be a little bit sloppy there, I guess. So let's go get the standard deviation. Same observations. Now we need to count. So we can see our mean and standard deviation are slightly different. We need to count just the psychology. So how many is in psychology will count? We'll drag this down. We'll see that there's 14 observations and numerical values for psychology. 1 minus this is 13. So now we need to, our standard error actually has been automatically calculated because it took the standard deviation times divided by the square root of this. So you notice that when we copied and pasted it, we pasted the functions relative to where these cells were, not specific values, so that now that this standard error is automatically calculated. A nice feature that you should get used to as you're starting to use Google Sheets more and more. It's always good to double check by double left clicking on a cell to pull up the function, to pull up which cells are corresponding to that function. So now we'll go to the critical T value. So we're going to go back to this calculator. Let's just go back. And remember, our degrees of freedom now, our alpha is the same, of 0.05, because we're using a 95% confidence interval. But our degrees of freedom, instead of being 59, is now 13. We're going to compute our T. And we'll notice that we get a different T value, which is 2.16, so it's slightly bigger than the previous one. The previous one was almost exactly 2. So when we click that here, again, we've automatically calculated the lower and upper CI just like we did with the standard error, because it calculated the mean plus or minus, or in this case minus the standard error times the critical value. And because this critical value is bigger, our confidence interval is now bigger. So basically the space of our confidence interval is widened because we have more uncertainty because our critical value is bigger. So now it's 3.2 to 6.52 is the width of our confidence interval. That's slightly wider than our previous one, which was in the, I think, the range of the 4 and 5, roughly, approximately. So this is one way you can get a confidence interval based on a subset of data. Now let's